So the value of the stock, we are given dv over dt. I have to repeat because I just now turned on the camera. I stopped it for a second before, so I put it on right now. So dv over dt, k is the constant, L is the limit of the stock, so we are given 24.81, and we're asked to solve for v, of course. So I have dv over dt, which is k. I have to replace 24.81 minus v. How do we proceed? What is this first step towards solving this differential equation? In order to be able to integrate, dt has to be on this side, dv on one side, dt on the other, right? So we're going to multiply by dt first. So dv equals k, 24.81 minus v times dt. Now I realize the constant is fine, dt is fine, but this does not belong here. This belongs with dv on the other side. So I will divide by it. So, and because I don't like it with a constant minus v, I'm going to first multiply by -1, or just factor out -1. Better, factor out. So dv equals negative k v minus 24.81 dt. And now I'll divide by it. dv over v minus 24.81 equals negative k dt. And now I'm ready to integrate. The right hand side is nice, negative kt plus a constant c. This side is that natural log of the absolute value of v minus 24.81. Like before, the imaginary e raised to this power equals that. So the absolute value of v minus 24.81 equals e to negative kt times e to c. I apply the property directly now since we applied it several times today. Okay, so now I am told this. V of 0, when t is 0, v is 20. When t is 0, which makes this 1, v is 20. So 20 minus this in absolute value will be e to c. So I have to go to the next page, sorry. So 20 minus 24.81 in absolute value will be when t is 0, this is 1, will be e to c. 20 minus 24.81 is basically 24 minus, it has to be a positive number, so 24 minus 20, so it's 4.81 equals e to c. So then here v minus 24.81 equals 4.81 times e to negative kt. Yes, I will move negative 24.81, it changes its sign. So the value of the stock is 4.81 e to negative kt, function of t of course, plus 24.81. Any questions? So for the absolute value, I would put plus or minus here, and plus or minus. And now we have one thing to discuss, because it says L equals 24. Is the limiting value of the stock. So since the limiting value is this, then I have to use only a negative sign. Since L equals 24.81 is the limiting value, that's the top. I cannot have the positive. If I have the positive, they will be over 24.81. So use only negative 4.81. So then V of t is going to be only negative 4.81 e to negative kt plus 24.81. only because this is the maximum. They're telling us that this is the maximum. So we cannot use plus or minus. Any questions? We can always come back if you have anything, or if you want to work on other problems. 6.4, sorry, deals with least squares technique. And I'll explain what this means. I'm sure you're going to like this. This is the easiest section of the entire course, I want to say. What is the least squares technique? And I haven't talked about chapter 6, what it is all about. This is really, should not be, in my opinion, does not belong in chapter 6. We did this in algebra. I did this in algebra with all my classes. So this is an algebraic technique. But why is it in this course? For that I agree. So let's suppose we have 100 observations, and they are in the form of an ordered pair. Let's say height, comma, age, weight, let's say age. So I select 100 people randomly. I will use a specific technique. It's a representative of the population, if you want, depending on my study. I select 100, and you are among these. I measure your height, and you tell me your age. So let's say this is Michelle. Let's say I am here. Let's say Amanda is here based on height and age. Let's say somebody else is here, somebody else is here, somebody else is here, somebody else is here, till I have 100 points. X, the height, Y, the age. So this is one person, this is another person, this is another person, this is another person. So after I plot a scatter plot, this is called scatter plot, I realize that there is a way of determining a trend. I see it's linear. What if it's quadratic? Then it will look like this. And then I will see the trend quadratic. But this is a linear trend. Could I see an exponential trend? Yes. Something like this. This is an exponential trend. But what is the idea of the least squares technique? To minimize the error in the model. There is a lot of error. It doesn't pass through any of the points. Maybe one, maybe two. I doubt that it will pass through any. But this line has the least errors, the least distances to the line. What about this line? This will be a tragedy, right? This is not the line that will have the minimum error for each point. No, this is the line that will have minimum error for each point. So it's called the least squares, because we are squaring the error and we minimize it. How do we minimize it? With calculus. Finding the function, finding the derivative, and set it equal to 0. To show that that is a minimum. That the squares of all the errors will create a function that has the minimum error. That's why 6.4 is in this course. When I present this in algebra, I cannot talk about least squares in the sense of minimizing a function. With you I can, because you know that you find the first derivative, you set it equal to 0, and if the signs of the derivatives are negative, positive, you know it's minimum. But my algebra students don't know that. I'm not asking you to do anything by hand here. So I'm only asking you to follow my lead and use the graphing calculator, as I will show you in a minute. with either linear regression or just these two, exponential regression. So what am I trying to do? I'm trying to find this line, or I'm trying to find this function. We're not going to talk about quadratic, just these two. We will enter the data in the graphing calculator, and you will see what happens next. We're going to get the function we want. So let's open on page 554. And let's choose any word problem like labor force, football ticket prices, life expectancy for men, grade predictions, anything you want. And I will share my screen right this moment, show you how to enter the data. But after I copy the problem you choose or the problem I choose. So we need to have it on paper first. 13. Grade predictions. Okay. Professor wants to predict students' final examination scores on the basis of their midterm test scores. An equation was determined on the basis of data consisting of the scores of 3 students who took the same course with the same instructor previous. See the following table. So I have in problem 13 on page 554, we have the x values and the y values corresponding because they have to be ordered pairs, right? 70, 75, 60, 62, 85, and 89. Find the linear regression line, okay? So, I'm sharing my screen. Where are you guys? I can't see you. Okay, I see you now. Here it is. So, let's go to Stat, Edit, clear whatever else you have, highlight the list and clear everything. We only need 2, but since I'm here, I'm going to clear everything. It doesn't, what is going on? Okay. Clear, please. Okay, thank you. Okay, so we have 70, 60, and 85 correspondingly in the same, in the same exact order, 75, 62, and 89. You could say, show me that this looks like a line, and here's what I'm going to do to show you that. I see that the minimum here is 60, the maximum is 85, 60, 100. So I need an appropriate viewing window. So let's say X minimum goes from 50 to 100. With a scale of 10. And Y goes from 50 to 100 with a scale of 10. Okay, get out of there for a second. Go to second and stat plots, second and graph function, second and Y equals, second and stat plots. And press enter for the first one. Turn it on. And this is the first symbol is the stat plots. These are other statistical graphing techniques. I have the X list in L1. I have the Y list in L2, correct. Use the mark you like. I like little dots. Doesn't matter, really. And now click on graph. Ah, it looks quite linear. Okay, so these 3 data points look quite linear. In the next step, I go to stats. calculations. Here it is, number 4, linear regression. Scroll down to 4 or just press 4 and make sure that you have list L1. How do I change it? Second and 1 is list L1. Second and 2 is list L2. Okay, if you have this kind of type of calculator, I also want the calculator to store the function directly for me so I don't have to type it in. So I go to variables and I choose variable 1 for function y1. So the calculator not only will calculate what I'm interested in, the linear regression line, which will be a line ax plus b, mx plus b, right? But it will also store that line in y1 in case I have to answer more questions. And now I calculate, enter. Here it is. The slope, the number in front of x is the slope, 1.068, and b is the y-intercept, negative 1.2368. There is no need, this is the correlation coefficient. It just says it's very close to 1, so it's very clear that it's a linear relationship. But we do not need the correlation coefficient or the correlation of determination. So these two, you may not even have them. Okay, so I'm going to write the line, which is y equals 1.0684x minus 1.2368. And this is the line that minimizes, that's why it's in calculus, minimizes the error. Okay, so now look at y1. So in y1, I already have this function. It entered it. The calculator entered the function for me. Thank you, calculator. Because in part B, it says the midterm score of a student was 81. Use the linear regression line to predict the student's final exam score because X is the midterm. So all I want to do is go to second and table and plug in what they want, 81. And it will give me the result, the final exam. If the student had an 81 on the midterm, the student will have 85 roughly. So when X is 81%, Y will be 85 if you want for 0.31%. That's all I'm asking you to do in this section. No other calculations are required. Now, how do I, and we'll select, let's select from 5 through 8. How do I do the exponential regression? So stats, calculations. So here it is. We also, the calculator now has quadratic and cubic and quartic. What I'm looking for is the exponential. Where are you, exponential? Maybe I should have gone up. Right here. So let's choose another problem. That's all I'm asking you to do. So find the exponential regression curve for each data set. Okay, so let's say problem 8 on 554. So I have X. I prefer the horizontal charts to the vertical ones. 2, 4, 6, and 8. And we have 13, 7, 3.7, and 1. So I go back. Let me share again. Let me